Hi everyone! Today I will talk about the principles of radiofrequency and Agnes. Radiofrequency is an electromagnetic wave frequency. It has been used in medical treatment for over 80 years. In medical field, RF used in range of from 3 kHz to 300 GHz. Unlike laser treatment, radiofrequency has no chromophore, so there is no selective thermolysis. But we can use radiofrequency for its unique characteristics. Frequencies, electrical conductivities, and the other factors. So we have to understand how RF works in our body. Basically, radiofrequency heating mechanism is like this. RF uses alternative electrical current. It means there are two poles, electrical poles, positive and negative, but it changes from positive to negative, negative to positive. If the change is 1 time per second, means 1 Hz. If the changes of this alternative current 1 million times per second, means 1 megahertz. So because of changes of electrical pole, the molecules between the electrical poles moves towards to their electrical affinities. So this dynamic movement can convert to the heat. It is the basic mechanism of heat generation of radiofrequency device. So there are many considerations in radiofrequency treatment in medical field. Basically, because this is an energy-based device, the Joule's role is the fundamental physical role. So Joule is proportional to watt and time. But the fluence, which is energy density, is more important in our tissues. The fluence is proportional to Joule, but reversely proportional to surface area. So which means the energy density is proportional to watt, the power from the device, and time, but reversely proportional to surface area. This is the same physical law in laser treatment. But the other factors affected at the human body response to the radiofrequency, waveform, and electrical conductivity, the different frequencies, the target temperature and time, and depth and size of target, which means sagittal anatomy of skin, and finally, shape of electrode. There are two kinds of waveform in radiofrequency. The square waveform makes less thermal injury to surrounding tissue than sine waveform. Agnes makes square waveform, so it minimizes thermal damage of surrounding tissues. Human body consists of various conductors, waters, proteins, fat, nerves, bone. Each component has different electrical conductivities. So we have to understand how different of these electrical conductivities in our treatment. As you can see, blood has high electrical conductivity because it is most likely water. But the fat tissue has very low electrical conductivity. So which means reaching to the melting point of fat tissue needs almost 10 times higher energy than wet skin. This movie shows Agnes can melt fat tissue very easily because it delivers high energy density with narrow or small surface area with an high watt power. But left side, which has a large surface area, and it is very difficult to melt down the fat tissue because of low fluence and low electrical conductivity of fat tissue. So we can understand if we need to melt down the fat tissue, we have to make small surface area of electrode, and we have to deliver high fluence to the low electrical conductivity materials. There are differences of permittivity by frequencies. For example, conventionally we use bulby in operative field. So it uses 0.48 megahertz. It is a relatively low frequency. That kind of low frequency, the electrical current flows surround the tissue, not into the cell. But over the 1 megahertz, this electrical current can penetrate. The target temperature and skin reaction in time is important as well. The slower temperature rise makes more bulky and necrotic field, but the faster temperature rise makes narrow skin reaction area. And when we use especially needle RF device, we have to understand the sagittal anatomy of the skin. If we look at this hair follicle structure, there are sebaceous gland and eccrine sweat gland and apocrine gland around the hair. The distance from the skin surface to the sebaceous gland is about 400 micromillimeter in our cheek area. So if our target is the sebaceous gland, we have to deliver enough energy to the sebaceous gland more than 400 micromillimeter. And at the same time, to minimize the thermal damage to surrounding tissue, we have to protect the distance from the skin surface to sebaceous gland 400 micromillimeter, which means the insulated part should be 400 micromillimeter in this case. So if you can understand the sagittal anatomy in the skin, and we can use radio frequency or the other energy-based device more precisely and safer. The Agnes is very unique radio frequency device because it uses a microblade pin with a monopolar, and also it has bipolar handpiece as well. Agnes has partially insulated microblade electrode with stopper. As you can see, this T-shaped design, so the shoulder of this needle or microblade pin acts as a stopper function. So anybody insert this pin into the skin, the stepping reaches to the same depth. And as you can see, the right side is covered by some little bit translucent material, which is insulation. This insulation protects skin surface burn during the treatment. The lower part is electrode, non-insulated area, which is the destroying part or the delivering energy part. There are big differences between the conventional fractional multineedling RF versus microblade small number pins RF, which is the Agnes. As you can see, the left side, the conventional multineedle devices has many pins, which means total energy from the device delivered into each single pins, which means each single needle delivers low fluence to the skin tissue. But in case of Agnes, 1 or 3 pins, the total energy can focused or concentrated in a single pin or triple pin. So it is very easy to deliver higher fluence than the other conventional fractional needling devices. And insulation is different. The conventional fractional needle RF has fixed insulation and fixed non-insulated part, but the Agnes has different insulated and non-insulated part on various needles. For example, in case of acne treatment, we can use I or C pin. They have different in length and different in non-insulated part, so that we can deliver different fluences to the sebaceous gland. There are one thing, a very important difference of Agnes is the Agnes uses not cylindrical needle but microblade pin, because energy distribution varies according to the shape of electrode. We call it this edge effect. The electromagnetic energy usually focused on sharp point, so RF energy tends to be driven towards the edge. The upper column is cylindrical needle. The cross section is round and getting sharp to the point, so that electromagnetic field is most concentrated in the tip, on the tip of the needle. The lower column is microblade pin. As you can see, the cross section is a hexagonal, which means there are 6 edges, sharp points, so that electromagnetic energy distributes more evenly from the proximal to the distal part of the pin. Cylindrical needles are composed of a pointed end and a circular body, and this structure can cause difference in electromagnetic field when electrical energy is transmitted to the skin. If the transfer of electrical energy between the pointed part of the cylindrical needle and its body is uneven, the electrical energy may not be delivered uniformly to the treatment area. Because of this, the effectiveness of the treatment may be inconsistent and it may be difficult to achieve the desired result. Microblade pin can generate a directional electrical field compared to cylindrical needles, because the cross-section of the pin can form a plurality of electrical field emission surfaces. This results in the following characteristics. High electric field characteristics. High electrical field characteristics are possible due to structure of blade pin. And we can get high energy efficiency when we use microblade pin. Compared to cylindrical needles, high energy efficiency is possible with less energy supply. Therefore, more effective skin treatment is possible compared to the same energy supply. And third, microblade pin get a high electric field effect. Approximately twice as high electrical field effect can be obtained with the same energy supply. This can improve the effectiveness of skin procedures and provide patients with the faster result. You can imagine the left first picture when we use needle RF. The heat distribution is very even around the needle tip, but this is not real because of edge effect. In case of cylindrical needle, the thermal damage zone is mainly around the tip of the needle. So we actually deliver the heat energy deeper than the needle length. But Agnes, which has polygonal microblade, so it can deliver the heat distribution in the skin more evenly than conventional cylindrical needle. This is comparison of real thermal image in the tissue. The left side cylindrical needle, the heat is mainly focused in the end of the needle tube, but the right side, the Agnes needle microblade pin, shows evenly distributed heat thermal damage in the tissue. And also, you can adjust the insertion angle when you use Agnes, not just perpendicular insertion. We can insert or step the microblade pin of Agnes, this kind of oblique insertion or perpendicular insertion or 45 degree angle insertion, so that we can use Agnes like an artist. Today, I had a talk about the principles of radio frequency and Agnes. So I hope you can understand more about the radio frequency and microblade pin Agnes as well. Thank you.